Hello and welcome to today's video. So today's video is going to be about electrolysis. Now, what is electrolysis? Electrolysis is the process by which you break water apart into hydrogen and oxygen using electricity. Oxygen is an interesting gas because you can use it to make things combust at a much lower temperature than usual, and hydrogen is an interesting gas because it can be explosive. Without further ado, I'm going to show you my setup that I'm going to be using and a little bit of the preparation of the setup I'll be using. Okay, so here is the beaker I'm going to use to hold the solution that will conduct electricity. Here are two wires that are going to be the electrodes that I'm actually going to use, but they're not complete yet. I'm going to use these carbon tips for the electrodes. They're actually twigs from the last video that I carbonized. Here I have two test tubes that I'll use to hold the gas that I'll be producing. So here we go. I'm going to add some Epsom salt to the container. Now, interestingly enough, I'm actually going to be using Epsom salt instead of table salt. And the reason for that is that if you use normal table salt, you can actually produce some pretty nasty byproducts such as chlorine and bleach. I'm now going to add the water to the Epsom salt. I'm going to let this dissolve for a little while I prepare the electrodes. I'm now going to use electrical tape to put these carbon rods on the end of the electrodes. There is one electrode done, and there's the second electrode. Here is the finished setup. Now to connect it to power. Flip the lever crank. That should have commenced bubbling. Let's see if the setup's even working with some scrap copper wire. I can use those electrodes. There's the vigorous bubbling I know and love. There should be vigorous bubbling, but that doesn't seem to be happening. Maybe the carbon is too resistant. I think I'm going to have to switch to normal copper wire. The reason I was using carbon electrodes originally is because they break down a lot less quickly than copper electrodes do. Oh well, I guess I'll just have to use copper for this time. I have successfully used pencil leads in the past though. Flip the lever again, Kronk. This time it should lead to my secret lab. Well, there we go. It's bubbling more slowly than I would like, but it is still bubbling. Let's see if I can focus on the electrodes. Yay, it's focusing. Can't see it quite clearly, but you can definitely see the bubbles finally coming off. I'm going to let this run for a while and see how much gas I produce. Alright, so unfortunately I was moving these test tubes around and I accidentally let some air get into the hydrogen side. There is one tiny benefit to having let some air get into the hydrogen though. Now it should be a decent mix of oxygen and hydrogen from the ambient air. So I'm actually going to take this test tube and put it in some water mixed with Dawn soap, and I'm going to make bubbles that I will light on fire. They should make a tiny explosion. Well, not really an explosion, but just kind of fireball. So I actually happen to have a much better idea than trying to somehow get the gas from in here into the soapy water. I'm actually going to put the electrodes in the soapy water and make a foam of hydrogen. Here's something else actually very interesting. So on this electrode, there's actually like this blue crystal building up. Now, Epsom salt is actually magnesium sulfate. So what I'm thinking actually happened is that copper chemically interacted with the sulfate ions in the solution and made copper sulfate, which is a blue crystal. Interestingly enough, copper sulfate is the salt I use whenever I'm making a solution to do copper plating, which might be a video in the future. I'm going to let this run for a little while and we'll see the results. Tiny explosions. Perhaps I'll come up with a better setup in the future and I can actually produce a decent amount of both hydrogen and oxygen. I hope you enjoyed that at least, and I'll see you next time.